Hey guys, you may have noticed the last stream was like super fucking short. It was like 2 minutes, but that's because my internet got cut out for like I don't know. I don't know how that works. I guess it just automatically reboots at 2:30, or I don't know. I don't really know. I don't know the ISP, bro. It's like public internet almost. What's up, guys? Let me get the chat over here. Where do I want it today? In the top left or the bottom right? Take my pick. Pseudo Archman SYU. You guys know about LLVM, the low-level virtual machine? It's awesome, right? And awesome because decomputes. But we're gonna be doing that this weekend. Something we're gonna be doing this weekend is gonna be low-level virtual machine stuff. Fucking LLVM, which is what it used to stand for, is low-level virtual machine. But LLVM is awesome. And I'll tell you why LLVM is awesome. I'll tell you why it's not awesome. So I think LLVM is awesome because you can compile for any target. So that's a good thing. But a bad thing is that what if it's not optimizing the best? But LLVM, I think, optimizes the best out of any of them. I think it is the best, and I think it optimizes the best. But like, you're relying on the optimizations afterwards because it compiles down to bytecode basically for LLVM and then compiles to the system. But the way it works is very interesting. We'll be doing a hella deep dive into it coming up probably this weekend after like the Arch installation and all the other shit that I plan. We're gonna take a look at the projects we worked on yesterday. I've been working on them and making some progress. I also open the file vec.d. You can use unit tests for safety, by the way. I learned that yesterday. You can technically put a unit test in these. If you compile this with LLVM dash 3.0 or whatever, or O3, which is optimization level 3, the most the highest level you can go in LLVM, you'll be able to target. Well, not target. You'll be able to fucking compile with. This is gonna be all pretty much done using the thing, fucking SIMD. That's what the great thing is that you won't have any real error checking or anything. It'll just be, you know, SIMD operations for these. Depending on the pattern, but since it compiles down to LLVM bitcode, yes, you'll be getting the best optimization for that if you use O3 of LDC2. Something I talked about in the Hexen stream is like, I'll actually say that for later. I'll say that for when I want to actually talk about that. Let's see, what other vibes do we got going in here? Alright, this section we need to work on because it doesn't work. We need to either import square root or write a square root algorithm. There is technically a way to do it using a Quake algorithm, or you can do inline assembly. But I don't really want to do inline assembly. Let me be honest with you all. LDC2 inline ASM. But we should be able to do it using inline ASM. We'll need to use the an LDC specific LLVM AR. IR? Yes, intermediate representation. But that's LLVM specific. So that'd be at compile time. Pragma. We'll need to use pragmas then to determine what to use at compile time. If I use dlang, I will use the regular ASM because it's simpler. However, if you want to get the most optimization, you would use the LLVM IR for square root. Which means we'll have to read the language reference manual for LLVM, which isn't bad. It's actually really easy. LLVM has its own variant kind of assembly, which is a lot more complex than NASM from what I see. But actually not, probably not. It looks actually might be simpler. Might be hella simple. Oh right, I also cannot see the chat. Did I set the live chat? Oh, perfect. Oh, let me give myself hearts, bro. Damn, bro. Cooking today. Kukarov. Kokoronius is my favorite Roman emperor. Here is an example to multiply the integer value of 8. Strength reduction. And is I32 like to say 32-bit register or something? Or is that integer 32, like integer 32? So in ASM you have a SQR, you have reciprocal SQRTSS or SD. Compute reciprocal of square root single precision. So is this an article we're reading? A science article? But that's one way you can calculate square roots without using D-length square root. And then here's here's a legacy SSE version. Here's the VX encoded version. Intel C/C++ intrinsic equivalent. SIMD floating point exceptions. So it's kind of complicated to implement assembly if you intend to work with templates and like all this complex shit. But I mean, like I guess that would be expected. And then there's also the Newton Raphonius thingamajig. You know about Newton's Raphonius? So like fucking Quake. So with math, bro, you got the fucking Quake inverse square root, which is one of the most interesting things in computing. Fast inverse square root was invented for a video game, Quake 3, bro. And I like Quake 3 a lot. I didn't know Quake 3 was so dope that some fucking math genius came up with a hexadecimal constant and a bit shift. It's literally what it is. You just shift one number to the right by a specific amount of bits, and you subtract this. This is for a 32-bit number. The 64-bit equivalent is different. The problem with this and implementing this with D-Lang is handling doubles and other types that aren't, handling types that aren't doubles in the T for template. So I want to avoid that. Instead, I'm going to try to use SSE instructions or pretty much these. Now, of course, that means I need to go to understand both LLVM and the assembly instructions. However, it looks like it shouldn't be too hard to do. And first, we're just going to get something that compiles as DMD and see if we can just compile it with LLVM. And if we can't, and we need to use the LLVM intrinsics to get it to compile, then that will be our next task. Is figuring out how to solve that problem. Potentially needing pragmas. That's how I'm going to solve the problem and go through each step. So we'll do square root, call it scalar. That's my scalar. Then we just need to figure out what we're doing next. So if you take type S and you were to take that and have that be the result, you would just use ref. Then you would call this as void. I do call these as void. So you pass a ref, and then you update each of the indexes of the array. That's an option. However, passing a ref to this means it will expect a ref. So expects T, but unless it references it as a ref, you have a basic network driver now. That's actually hella cool. No, I deep dived into square roots because I don't want to have to import the fucking D-Lang square root. Because if I import it into the module, then I'll have to import it into my main program. Anyway. And then I might declare a T of R equals 0. This is one way of passing the output. However, this is really good if you want to just pass... But I don't think D really supports programming functionally super well. We'll try to take it as a ref. Ref T. Now, that's going to be... We'll see how that works. It might just throw an exception at compile time. So that's fine. So you can use... from XM8 to XM15. Oh, okay. So we'll declare ASM. If you use ASM, it might actually be easier to get a return value. But at the end, you just take T of S, and that's going to be the last step. So you would do move SD, and then T underscore S. And I think you put a comma, and then the next instruction, which is going to be XMM0. We'll do mol SD equals T underscore S equals XMM 0 times XMM 0. The R square root SS equals, and it is SS, correct? V is 128, by the way, so... There's also that option. You could technically implement a 120-bit version, but I'm not going to do that. Trying to think. Do I mul SD before I do this? No, actually, you move SD. T underscore S, move SD to that one. Then you get the reciprocal square root. So XMM0 both times. And that will pass through the ASM. Hopefully. And then at the end, I think we'll call this a void scalar to avoid functional programming as much as possible. Square root underscore scalar of T mag, which is the magnitude of a vector. Vector magnitudes are also interesting too. So a magnitude is where you take... Here, let me get the whiteboard for everybody, since the whiteboard will be important today. video tools, and then GIMP. Oh, nobody needs to see that shit. File, new. All right, here's the dark mode version. All right, let's say we have, for example, some array like 3, 2, 4, 6. We have another array, which is 0, 9, 7, and 11. So we have 2 arrays. The indexes of the arrays kind of go together. The lengths are the same. It's a requirement. So same length is a requirement. If they're not the same length, it won't work. Because then you'll have something that's not the same length. They just don't work. Like, it'll throw an exception in your equation. So that's the first thing. You need to check that. So you need eval for same length. So you do eval that. So 1 eval length. So the first step is eval. Checking length. Step 2, we will then iterate through the numbers. So we need to take these 2 numbers and add them together. Or, well, actually, I think it's multiply them. You actually multiply them. Let me see my equation real quick, because I don't recall what exactly you do, but it's this one, dot vec. So to get the dot value of the vector, of 2 vectors, you do this. Now t of r equals 0. Right, you have to return an array because oh, you have to return a type. Oh, it has to make a value. So that makes sense. But yeah, we just gotta for each through to the length of the arrays, and multiply each index by its corresponding pair. Then you add up every index. So that means the actual function would be like x equals x plus a1 times b1 well, actually, an times bn. That's the actual equation if you were to write it mathematically. And so that means also this needs to be, no, there is no x of n, but x plus equals, yeah, this looks right. I'd assume this is correct. I don't write math formulas, I write code. But anyway, 2, iterate, mul, and then 3, add. So after everything's been multiplied into one index, then you just add it all together. So that's how you get a scalar value out of 2 arrays. 3 arrays, don't even know yet. I haven't thought that far. But that's how you get the dot value. The dot value is important, because the dot value, when square rooted, gives you the actual magnitude, which is important. So the actual length magnitude is the root of the result. And so once we get to this section here, or once we get to here, that becomes important because the magnitude is needed to calculate a normalized vector, which a normalization gets you the direction, if that makes sense. So these are super important functions for vector math, which is what I'm writing. I'm going to write my vector math equations so we can build super quantum Grok, who's going to live in the ether, and Elon won't be able to stop us because we'll build a false data center together on YouTube. That's the plan. So anyway, let's see. So CPU feature flag is SSE. And then another CPU feature flag would be AVX. So that's for like that one. Instruction operand encoding. Anyway, you'd follow up this one with the Newton-Raphson. So Newton-Raphson step by step. I still don't really understand Newton-Raphson. But from what I recall, you kind of just add things and then there's like two constants. It's like 1.5 and something else. Newton-Raphson method. Huh. Oh, okay. That's cool. Here we go. The way they explain it, like, makes no sense. It's like looking at an alien language. But I'm pretty sure it's just as simple as, like, doing x equals... x equals the half of what you're trying to do. But this should just give you a reciprocal. Then you get the square root by running it through one iteration of the thing, the Newton-Raphson. So the result, if the result is going to be t of s anyway, t underscore s now needs to equal t underscore s times, like, I think it was times, no, minus. See, there is a minus. So it equals this. And then half of its original value, which would mean that you would want t to declare another value, t underscore r, which is going to be the result. And then at the end, you set it to that. But the reason I want to set t of r is because I want to take equals t underscore s t underscore r divided by, like, what was it, 2? It needs to be divided by something. You cut it in half, divide it like that, and then you just do, I believe, multiplication afterwards. Like, here we have NumPy. Where can I find the project? This one? I haven't done much. I haven't released this yet. I haven't put it out yet. But I don't know. I'll probably post this on my Codeberg later when it's ready. I don't like to post things there much, but like sometimes I do. So we need to take t of r or tr and divide it by 2. Then we need to multiply it. I'll probably post it there after the stream if I remember. I actually don't remember what I wrote yesterday for this one. But it's safe to say I just got like really tired of trying to write this because I couldn't get to compile, and I was like, yeah, no, we need to scrap that. What am I looking at? Hyperbolic functions cheat sheet. But math is important. Math is the building block of computing. So our equation is a bunch of x's. But yeah, you can pretty much reuse the same variable for like the whole thing. Alright, here's a Python code to calculate this. Good. Oh. X equals A. Ah, so that's how they keep the A value the same. You just set T of R to equal that. Let's set T of R to equal 0. Then T of R is just going to be here. Here. And then C of S will be here. But you also need to multiply stuff. Because you have a couple constants you have to do. You want iteration to find the actual one. Alright, unless there's a square root st commands for ASM. Of scalar single precision value. Oh, okay. You could really just call square root SS then. Okay, we could probably just use that. I don't know what the difference is between R, SQRST, and then the other one. SQRT-SD. But actually these are SS, not SD. I think we'll just use the SQRT-STS afterwards. So wouldn't you just call... I guess you could just call the SQRSTS. I like how they have like assembly instructions now that are like so advanced compared to like what you'd think they'd have back in the day. Because back in the day, they probably just wrote out this shit and like did it in vacuum tubes. Would you just pass two to refine it? Because you kind of, when you have a reciprocal, it's not the best way, but been profiling our core math on an Intel Core Duo Microsoft assembly, NASM supremacy. Bro, I like LLVM assembly. LLVM bytecode, bro. They also have their own LLVM assembly too. Bro, LLVM cooks. Inline float tested square root function. Is this C-lang, by the way? No, that's not C-lang. That can't be. It's got a void. Is this D-lang, by the way? Slower than RSQRT. Compiles to move SS, SQRT, SS, and move SS. Newton Raphson. Does C-lang have voids? I don't know. I thought it just has int. It's probably that was probably C++ I saw. Oh, I guess it does. Absence of a value. I don't know. I just always declared the main function as not having a value. I guess it is. Also support void pointer. It's derived from C and algo. Okay, yeah. It has void. D-lang has voids. You know what's great about D-lang is that D-lang is an actual modern implementation of lang. So everything C++ can't be, by the way. I don't know if I'm gonna even bother with this. I mean, if I just want to avoid importing the library, I could just literally have it import, if this is called import... Wait, where's it at? Oh. If this is called import, the thing. But we'll see. We could also just... I think it'd be faster to just do that, honestly. Or write it in C++ and then link to it. But I don't want to bother with like CABI. I know C++ and D-lang have access to CABI. Maybe it's possible to interop like that and do some weird... But you could just interop directly with C++ from D-lang. Although I wish there was like more like shit out there like that, like an F-train, Fortran, D-interop. Hopefully we see that someday. I just like interoping with languages, bro. Odin's pretty fast though. Odin's like a gamer language, and I bet their AST compiles down really well to like things. I bet they also use. Do they use LLVM backchain? I wonder. That's like a good question to ask. We're gonna compile LLVM this weekend. By the way, we're gonna just do this, and that should work. But we need to call some things, too. We need to import D-lang core bro, I'm saying. I bet it's pretty fast. I like the syntax, too. I haven't really messed with it much. But it's something I would looked at for like externing to for like math operations and things. I believe this is something I can import. Core.math : square root. If not, we can just do it a different way. But it only takes floats, doubles, or reals, which is an issue. It is really fast. Yeah, that's what I was thinking. But we'll see how this works. With compiling it. Let's shrink everything down.
36M Chester, 01233N. 11. Its daddy is in a pinch. Sun's business model is being undermined on two fronts. Cheap Intel processors of the same type used in desktop machines are now more than fast enough for servers. And FreeBSD seems to be at least as good an OS for servers as Solaris. Sun's advertising implies that you need Sun servers for industrial strength applications.
But they're cool though. I want a Sun server.
First in line to buy Suns, but when I worked there, the servers were
what language is this?
running FreeBSD. This bodes ill for
D-Lang?
Sun's future. If
I'm
Sun
writing
runs into
templates in
trouble,
D-Lang.
they could drag Java down with them.
Hold on. Let me pop up my
36M
templates.
Chester, 1C++33N. C++, glacial compiles, insane complexity, impenetrable errors, laughable cross-platform compat, basically useless tools. Aaron Budeman.
Thank
0
you.
M.
Thank you, Jester, for helping me today. Jester curing depression today. Depression is C++. cdd underscore lang / vector lib. Well, I guess we just handle everything as a float. Everything will just come out as a float. Even int will come out as a float. If it is an int, pass it to be a float. We'll learn to write more advanced templates to do that. Everything double, 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 float, float, float. One of those two. Alright, then,
36M Chester, 0 C++33N. C++ is the best example of second system effects since OS 360. Henry Spencer.
Thank you so much.
0 M.
Jester, I love you. Damn, it compiled? Holy shit. I didn't expect that to happen. Alright, then /externed. Is that what we're looking for? The direction, I believe it would be. Let's say you have a number like, I don't know, like negative 234. 234,000, yeah. That's exactly what I expect. So this calculates a number that's going to be a double or a float. It's going to tell you the direction. So arguably what this can represent is like, damn, this makes sense. I was like kind of confused what it's going to actually do, but no, it makes real sense what it's doing. Not what it's what I wrote doesn't make any fucking sense, but basically getting this is like representing the speed of an object. Like let's say that negative 234.00 is a speed of an object or something in a game, right? And that's like the direction, how much it's moving in said direction. But arguably that's not really the case. Magnitude would be the direction, and then what would actually be this number. But I mean, this kind of represents somewhat of a percentage, but that's not what it's for. It's to actually tell you where it's like, is it negative or positive? I think that's what it's for. I don't know. Somebody explain normalization in a way that makes sense to me. This shit kind of confusing, but like, basically, I was told gives you direction of a vector, of a scalar in the vector, which is useful for machine learning. So when we create super quantum grok the third to destroy planet Earth with my T410 Power Edge server, it will be very good. After we compile again too for the Odroid M1S again. So that's why I'm writing this, by the way. This is math. Anyway, let's see, find useful math functions for, my next math problem to solve. Oh yeah, if you guys weren't here, I talked about the Quake square root, which is actually insane. Quake 3, bro. Quake 3 inverse square root, the fastest square root of all time, of its day, of the 90s. Yeah, fastest square root of the 90s. Squirt maxing. Squirt. What are we doing though? So we don't even need to do anything with LDC2, I don't think. But let's see about what comes next. Common vector math calculations. Vector math is fun. Yeah, I think so as well. Direction and magnitude. So like magnitude. Direction just means how much it goes in that direction. A vector has magnitude and direction. Despicable me, magnitude, and direction. I bet I think that's a thing. Bro, yeah. It's got magnitude and direction, bro. Magnitude and direction, bro. He likes vector math. Bro, honestly, knowing Universal Studios, they probably did this. What are we making, brother? My own vector math library, because I felt like it would be a cool idea to explore and understand vectors today. I can't wait till it fails to compile and we get to hear Jester 2 again. By the way. D-Lang? Yeah. I'm the legendary D-Lang enjoyer himself of all time. Let's see. Head to tail. Add two vectors by joining them head to tail. Doesn't matter which order we add them, but the result is the same. What is this? Pythagorean theorem? By joining them head to tail. So A plus B or B plus A. Why not use Visual Studio Code? I use Go, by the way. Oh, that's cool. I don't like Visual Studio Code. It's like Microsoft. I like open source, so I'm going to use Cape. So if we took DA Vector 1 and DA Vector 2, I think we can just take those and put them through a template. Let's declare our next template then. We'll call it void. Does this one take a reference? I don't know if I can take a reference. Actually, we'll be able to make a reference. We'll just use the original one and append to the second one, or something of the sort. So you would add A plus B or B plus A, but they are the same because the order doesn't matter. So if you were to add Visual Studio Code as open source, I don't know. I don't know. I'm a Kate enjoyer, okay? I like Kate. I've been using Kate the entire time. I'm probably going to continue using Kate for the next century. It's like how there's people who use Vim, but like Vim is something you can't really diss on. Vim is like the fucking god of text editors in the terminal. Vim is awesome. I would say Vim would be, if I didn't use Kate, I'd use Vim. Let's see, _vec. What is this one called? Head and tail. So this is join _vec. I'm more of a back-end dev than anything else. Haha. Yeah, I don't know. I just kind of do whatever is interesting. I like to show off stuff. Maybe people will be interested in it, and then they'll be like, yeah, let me also get into programming or something like that. Kind of like a inspiration for people. That's what I want to be. Try to inspire people to learn stuff. Because I try to learn as much as possible. That's what I'm doing. It's kind of works. I don't know. We're gonna take a T array, or two of these. We're gonna have TA. Backend is fun, but I like designing front end too. It's like I don't even have really a degree in any of this. I just kind of do it. I could get a degree in this, honestly. Honestly, if I could do that, well, I could do it. I just need to go to school for it. But that doesn't matter. Let's focus on what does matter. That's adding A plus B. Join vec literally just takes a reference of T. We'll pass this as a reference. Let's see if that works. Ref TA1. I do like revivals, aka Roblox, Fortnite, whatever sounds fun. I main Golang. I haven't messed with Golang, but I heard it's pretty interesting. I saw that there's a Rust variant of like all the Linux tools. I'm like, damn, bro, somebody's writing Rust for this. I wouldn't pay for a degree right now because the job market is saturated with AI users. Yeah, but I have benefits, so I could probably work those to get a degree in. But yeah, you're right, because you know what they want? They don't want people who can use their brains. They want AI users. They want people insufficient for the job. But it's okay, because I'm going to build Fish data center. It's going to be the best thing on planet Earth. My data center will be good for society. Trust me. TypeScript uses Go now? Isn't Go made by like Google? I don't know. But like, that's pretty cool though. Yeah, I hear a lot about Go. It's like also like how I hear about Rust. But I don't really know much about the Go shit. I barely know anything about the Rust shit. I just know I don't like Rust. So that just will change TA1 to that. But also, what if you don't want to return it? What if you want to return it, but you don't want to return it? Like, what if I wanted to have it as a void, but also wanted to set something equal to it, like a functional programmer who's writing Haskell still for some fucking reason? Which I did try Haskell. I didn't really get into it. I was like, this paradigm doesn't suit what I like to write. Maybe I'll try it though. So we're gonna join _vec. Let me make sure my code isn't bad before Jester2 yells at me that C++ is a horrible language, and that I should burn in hell for using D-Lang anyway. DA _ vector 1 and DA _ vector 2 dot write ln. Just to test it and give an example. Fuck Rust. I dislike Tory apps. Rust is so fucking slop, bro. I just look at Rust and go, yeah, Jody Brucon, he's right about it undermining the Linux kernel and the GPL. I don't personally dislike Rust. It's a programming language I'd probably use, but the community is atrocious. Yeah. Bro, it's got all the young programmers. People like me, but like less sensible. Like I'm a young programmer. I've only been programming for like 8 months, but like it's got all the ones who are like unsensible, bro. All the AI programmers who are AI generating their brains and intelligence. See, like I kind of respect people who programmed. Well, you know, you have to respect people who programmed back before AI because they had to learn all of the stuff. So let's see, where's my thing? Here we go. I'm not using this for backend. I would just use Golang, TypeScript, or C++. I just like D because it's the first thing I learned, and it's the first language that's ever made sense to me. It's like the thing I was able to pick up and then be like, damn, this works when
36 M Chester.
C++ and C didn't for me.
C++ is the only
Now I can learn C though. I could go back and learn it.
Bertrand Mayer. 0 M.
C++ is the only current... Okay, thank you. That's very helpful, Jester 2. If you couldn't tell, I use Arch, by the way. It needs a ref, by the way. Oh. You don't do this. You just would append. However, you wouldn't want to append this. Never heard of D, but I'll try, I guess. D-Lang's awesome, though. Like, it's got hella stuff that will be awesome. It'd take me, like, hours to go over all the features. But, like, you can look at a lot of my videos. I could technically, right now, be calling writeln like this. Or, and then put, like, shit in there. It's kind of like, could be calling it completely different, could be calling it like that. I could do, show some of my other codes off that I've written. Some of these other ones are like super interesting, like Jester 2, I use a class object. So you have classes in D. I use Catchy, which is forks from Arch. Yeah, I also have a Catchy system. My one of my Dell Optiplexes has Catchy on it. It's something we set up for like gaming. I play Half-Life on that thing. I tried playing Skyrim on it, but the 4th gen i5 isn't very great for retro gaming. This code is super disgusting. See, I only recently started doing a new format for how I write my code, which is like, I do a space here, and then I do this here, and a comment can go on this line, but no more than like one line comment, unless I need like a multiple line. I'm happy of the LARP of Windows. Good I got off Windows. I'm saying, bro, I wouldn't have learned to program. You can do like a scope exit, right? And this one closes a file. So I have this scope here that closes a file. You can also declare constructors, which I think is pretty normal for like a class or object-oriented language. Jester 2 is also available for download on Codeberg. So feel free to check that out. It's on my Codeberg. Jester 2, my fish video. Holy fire background, what the fuck? My background? Yeah, it's hella good, by the way. In fact, I actually have 6 backgrounds because I have FVWM3. So, did bro try Holy C? Not yet. I also have tried a couple different languages to program in. I've tried C#, which was like a phase, but like it didn't last more than like a week. I only really do other languages. I have to make a Holy D epic. I have to make Holy D epic suggestion, by the way. Yeah. When was the last update I did on Jester 2? Well, I think I did an update yesterday. Jester 2 is a Java tool for C++ devs that makes life easier by providing easy access to the docs. So if you need documentation, C# is what Java wishes it could be. Bro, I'm saying, well, Java's cool though. If you get like Sun computers, I bet Java would be hella cool. Like you could be like Sun Microsystems LARPer at that point and do LARP maxing. Did I try Go? No. I've tried Odin, VLang. I've done a little bit of C, but like, I heard you can make .dlls and exes now. That would be actually pretty cool. What is Golang like as far as like garbage collection? That'd be like my concern. Runtime and wait, Go can compile to a native exe. Yeah, that's actually hella cool. I think the next thing I want to try is Ruby. I also did Fortran, and I really like Fortran. It's like the one that I think makes sense to have as a second language. I added a bash RC example. This is to allow you to have it always spit something out whenever there is an error. So if you really are feeling down about those errors, um, the bash RC is available to cure your depression and tell you that C++ sucks. So that's why you're struggling. Also, this is for Java and C++. So this example only is for C++ devs. I don't know how to write bash RC files. I might even release my desktop as a configuration, honestly. Or make a system image. Let's see, where was I? Oh, yeah, I just had to change the pen. Let's see if it works now.
36M Chester, 0 C++33M. Why did the C++ programmer bring a shovel to work? They were tired of dealing with memory leaks.
That's so good. If you guys have any to supply me with, then let me know. I'll put them in there. Honestly. So we're trying to set that to equal that. Let's see. Why did I declare it as ref? What am I fucking doing? I am become jackass.
36M Chester, 0 C++33M.
Void.
C++ is a language strongly optimized for liars and people who go by guesswork and ignorance.
Oh, that means it's updating the value. Do any of these return? That's why I'm using write-ln. That's why TypeScript uses it. That makes sense. Let's see then. So if we have extra D and we're... So a void wouldn't... a void would set the first array to be the second one. So then we'd just be like... Or to be the actual join of the two. So DA underscore vector dot write-ln. Boom. So that joins the two arrays together. Now you have a vector of 6. Cool. Let's see what other vector math I can do since we're cooking on this vector math stuff. Go's icon is so fucking cute, bro. Flat icon. 171998 3 icons of Go. I could have used .d for my offset finder. Bro, like, D is hella cool, but like Fortran, if you want array mat or array stuff, you should check out Fortran. Fortran is like the king of array handling. Oh, go lame. Go lasagna. Oh, damn, bro, it's a beaver. Wait, is this a beaver? It's a creature. It's Galorbus. What is Golang icon? Is he Galorbus? Jamogus. I think so. Yeah. Beaver. His name is Galorbus. Alright, let's go and check the vector stuff again. So we got the magnitude of it using the other one, but joins like to combine two, so then you could find a different magnitude. We can also subtract one vector from another. First we reverse the direction of the vector. We want to subtract, and then we add them as usual. Oh, wait, that's... So adding a vector... Join them head to tail. So this just appends them, but doing is D good for like offsets? I don't know. I don't know what an offset is. I haven't really messed with that. Offset. An offset is an integer value indicating the distance or displacement from a defined starting point. I mean, I don't know, like maybe. I don't know. I think it would be. I use offsets for Roblox sheets. So here in this example, okay, so you take the propeller, then you add it to the tail of the other. So if the wind is coming from this direction, the tail of wind goes there, and that means the direction of the airplane is this way. What the hell? So you need to figure out what the values are. So we need to create a formula that tails the vec. So if we have a vector, let's go make another whiteboard example on Arch User tab. Video tools, GIMP. Just make a whiteboard example. Alright, the whiteboard, of course, in Darko mode. Let's say we have 3, 2, 4. And we have 6, 8, and 7. And then we need to find the tail of one vector, which I don't really know what that would be, but I'm guessing probably is like the lowest number of the vector or something like that. But like you could see that the position was like represented, like it could be like a representation of a position or a speed. So like if wind is going this way, and then you have the tail of wind is this. So what is a tail in mathematics? Mathematic tail of vector. So a tail would be like this is initial point of origin. Vectors are defined by their magnitude or direction, rather than absolute position. Because you wouldn't have an absolute position for every single vector. That's interesting. You would just take you just take like your magnitude, and that would be the position, tail and head. So the head's the front, but the tail's the rear. So then, how do you find head or tail? But the question to that can easily be defined when you have direction, but also magnitude. So magnitude could be the head and the tail. And if we know the direction and magnitude, I think we could figure out what the position is based on that. So an inverse magnitude, which you can get magnitudes from using square ln vec. So we'll define two new functions then. two new templates. We'll call one the T, and call it magnitude of vec, or magnitude, and then scale. And then we'll also magnitude of scalar, and we'll also define that with shift T, and then take a T from take a T array. So you take a T array, TA. At this point, we'll declare the import in the main of the file. Well, hold on. I think we could just define this in, but like, shouldn't we just import it with the rest of the file? All right, import this here. That way it's global, and the module declaration at the top. So we got our vec, and we're declaring that as TAV1. The reason I do TAV1 is it defines that TA, the type array here, and then it also puts what it is, which is vector1. So an array, a type array of vector 1, which isn't to say that it just defines what the vector is. We don't know what the type is, so all these types are just like, well, it could be double, could be int, could be ulong, could be float. If it works with those, I'd be surprised, because we're using square root, which is said it only takes like floats and doubles and shit. So hopefully it works with like anything. Otherwise, it might return a float, so who knows. But this is like lazy programming, is like what I think it's called. We're going to take that and we're going to return a T. So the magnitude scalar and then the inverse magnitude scalar would just be gotten by, copy this, and then you would do an opposite of it. So I would declare that one as like inv, the inverse. So you would just have an opposite. So what all these are going to do is they're going to call squared ln that. So we will call our squared ln vec. But we're going to do sqrt and then squared ln vec, and then pass the TA of v to it. So that should work and give us a square root of it. And then the return value, I guess we should just call that with the return and do it all in one line. I wonder how well that's gonna work. That structure looks fucking like an original fish structure that I just wrote. So if we do this, we also need to divide TA vec in one of these by specific value. Well, actually, you could just multiply it by the opposite. The magnitude is literally just the length of it. So if the length of a vector is like 2.14 total, then the original position would be like here or like there. So that'd just be, so if the magnitude is 7.6, then if you wanted B, you would just, well, how would you find a point on B? So this has a length of 7.6. I guess 0 could be defined as this one or that one. But what if there is no definition of what the length is? That's like a great question. But to find the head and the tail is an important thing. Return negative square root or SQRT. I mean, I think you want to avoid squirt. Return this, but multiply it by -1. And then times negative. Well, actually, I do inverse it here. So, in this case, we take and divide 1 by square root. And that's to normalize. But why do we do that in normalization? So normalization, you take this and you get your magnitude in the first step. And then in TAV1, you have the array, which is returned if the magnitude equals 0. If the magnitude returns 0, that means that it's not possible to do the rest of the normalization because there is no size for the vector. So then to get the T_inf Tmag, we do T1, so integer float 1, or whatever it might be, divided by the square root of Tmag. Let's do that here. Which gives a inv Tmag. So that's the inverse type magnitude. That's beautiful naming. Return T of 1. That should be fine. Now, when we call it... So let's go ahead and just check that it can compile still. Because that's my first check. Yeah, it compiled. Still compiles even with the module being declared at the top. And then, of course, we'll call the other two functions, which are the inverse mag and the regular magnitude scalar. Which we just have an inverse here for some reason. We'll call T underscore magnitude scalar. And then the inv T magnitude scalar. And that will be the two that we'll use. And those are returning magnitudes. So that's the inverse of this. Or like, looks like it's just the second half of that. I wonder how we get this number out of that. But I guess that's inverse. So that's the scalar for dA vector 2. It doesn't change them, by the way. It all it did was just adjust them. But you can also see that square root is no longer working. Oh, it's not actually square rooting them. What? Pseudo what the fuck? See, it's not actually square rooting them, which is important. Because otherwise it's not even returning what it's supposed to. But if these are called, it needs to have this. There we go. Wait. It returns the original... Oh, that makes sense. Never mind. I'm dumb. I thought it wasn't even working. There is no more random imports of rogue fucking square root. But yeah, that's just appending the two together. So, if we're taking the two and we basically take the end of one. So, how does that work? We can add two vectors by joining them head to tail. And it doesn't matter which order we add them, we get the same result. So if you did B to A, you'll get the same result as A to B. Because it's a triangle, and everything revolves around triangles. I'm being dead serious. In math, the triangle is like the fucking god of math. Everything can be dumbed down to triangles, the number 180, and it's a big conspiracy. But that's just because of how our math system works. It's magic. You can also subtract them. But wouldn't you need to find a position? Do you even need a position? So if the head and the tail of the thing are those numbers, then the length of the line shows its magnitude, and the arrowhead points in the direction. This is a vector. Vector has size and direction. The length of the line shows its magnitude, and the arrowhead points in the direction. Play with one here. Oh, hey, I can define the magnitude. Doing. Oh yeah. It's so long. That's perfect for a that's what she said joke. Got him. Lol 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 lol. Anyway, the magnitude of this square. For example, if you take a square and you divide it up, the magnitude of this square is 9.5. By the way. Actually, the magnitude of this square object is 22 point something. 22 jabibis. R jabibis, by the way. Let's see. Math is fun? Hell no. Bro, but math is fun, though. You just gotta get into computer programming. The next thing you know, you'll be like a math addict. Be like, damn, bro. Math is like crack. Every time I do math, I just get a nice high afterwards, bro. That's math for you. Math in summary. Add two vectors by joining them head to tail. But what is a tail? Tail of vector AB is the initial point A, the point at which the vector originates. The tails of a statistical distribution with property P of X are the extreme values of X. So a distributed tail would be like if we take for the other example that I was trying to do, but like we took that example and we did it's the extreme one. Tail of a vector or tail of a statistical distribution. And we want the statistical distribution. Tail of statistical distribution. I think I'll try to do both of them, but I don't know. The extreme ends of it. So whatever the highest number, you would just reorder them from highest to lowest and then add them together. Right? But sometimes you wouldn't want to do that. You'd want to take a copy in some cases. In theory, this version is not a distributed version. However, we would... Okay, I understand this now. See, I'm thinking of it way differently than what I'm supposed to. So you would take the two scalars of these, and you'd return another scalar. So basically, what happens in this equation here is what I just did, but you add the two together. So this is not add vex, but this is like, I guess if you're doing lines, then this is what it is. However, add vec is already taken. So add vec was not was just adding each corresponding index. Maybe I would redefine that. Technically, we could call addVec to replace some of the functions. No, actually we could. Not here. We have the dot of a vec, we have a division of a vec, but that's not like actually how that works. Well, actually, what if you just added up two vecs and took the dot length from that? We'll see. So let's take instead of appending to that one, we'll set that one equals to the result. So we'll have a TA res, or just T res. Actually, let's just return a type. Returns T res, and I think we can definitely pass these as references because they are arrays. But we're gonna take the two arrays. We're going to declare T and then T result, which is gonna be TR equals 0 semicolon, and then you can call the rest of the stuff. So you do TA underscore v1, right? That's gonna be inside of the square ln, so we'd call squared ln vec. Actually, square magnitude. So magnitude scalar and inv magnitude scalar, and we want to get those. Thanks to the reverse calling syntax, I can make it look beautiful, right? You want to see what I'm gonna try? TA underscore v1 dot magnitude scalar. I want to see what that does to it, if it can compile like that. If it can compile, then it will be amazing. It'll be John Amogus. Then we just take those two, and then and this isn't add vec, this is add in dice. So these are add-ins, these are sub-ins, mol-ins, div vec. So I'm going to redefine those, because this one is technically add underscore vec. So adding two vectors, we just got ourselves the result from that. And that's just by doing a simple adjustment to this one, where you do TA v2 and TA v1's results and set T underscore R equal to those, which should be perfect. I should be able to do that in one line. This is a weird way of doing it. I don't think I've tried this yet with my own type template. Using a template to call in the reverse function calling syntax is insane, but it makes me go crazy. Let's see if we can do that and not have Jester tell me that C++ is a shitty language. But where is my thingus?
36 M Jester, 0 C++ 33 N. C++ is the only current language making COBOL look good. Bertrand Mayer.
Thank you, Bertrand Mayer. This is amazing of you to say such things. Ah, good. It actually works. So now we'll get the magnitudes of both scalars, write them out, and then we'll add the vec for the scalar. We'll get the magnitudes for each of the vecs, and we'll write those out, and then we'll see what it is. As you can see, we now have returned this value. Add vec dA vector. Okay. Oh, I forgot we need to do dot write ln after this. Since we're using, I like to use reverse function calling syntax a lot. So let's see. Yes, they do add up. So it doesn't have the same precision though. That's the only difference, is that it added it kind of rounded all of these up, but that's fine. We didn't need that anyway. So that is the sum of the two, which is like negligible because like, well, obviously we have negative 2,430, but like, what if we had like 4 in my vec? So I take all of those indexes. The result's actually way different. See, if I have a full number here and not negative 2,400, then the result is significantly different. You actually get a different sum of the two vectors. So if we were to draw those out, like I have 6 here and I have 0.1 length there, which results in the 7 number. That means the relationship between the 2 points is also included in this equation, because you can see here, like, you have this, and then you also, well, you have this point, but also that point. So this is actually making a triangle. I bet if you add up all the values, you get like something that could be divided down into like a triangle's angles. I'm not sure what type of triangles that would change the equation, but like this is kind of a triangle, essentially. It is definitely a fucking triangle, bro. I'm telling you, it's gotta be a fucking triangle. Triangles are math's fucking god, bro. You think Archimedes, bro? Hell no. Arch Linux. But actually, Archimedes probably was the first Arch Linux user. And that's what they need to teach in school. I'm sorry. I'm sorry. I'm getting sidetracked about making some fucking weird joke. So it's really weird though, because like maybe the two vectors aren't related, but maybe they are related. It's kind of something to think about. We had like we had 4, we had like a bunch of these numbers, but what if, well, these in and of themselves are technically able to represent a triangle already. If you have 3 points, you can represent a triangle in one vector. You could just say 3 points for my vector. But if you're representing a length, though, these aren't lengths. Like this would be like, we have a point at 1.205, we have a point at 3.141, and we have a point at 6. But these could also represented 0. These could represent not points for like a triangle, but like something else, like an index of something. Your computer needs to restart. TOS stopped because your kernel encountered a problem. Unhandled CPU exception, page fault. Detailed diagnostic is available on serial. Ooh, wowie. Make it more bug check shaped. What's going on in tech maxing? Good. I'm glad somebody tried CatchOS. Catchy's awesome, by the way. Not real without fastfetch-c/examples 31. Damn. Alright, let's see. dA vector. Okay, so to subtract them, you do the opposite. So that says t sub vec. You just subtract in this case, and then you would sub the inverse square root of 1 from the squared length of the other, right? Well, you can add them head or tail and it doesn't matter. That's just like typical addition. Oh, but it's head to tail. So we found the head, but the tail is... Well, wait, what's the difference between tail and head? Would my head equation be right? No wonder it couldn't find a test file. The extension somehow changed to HWSL. Write a Java OS. Giga Chad sells write Java OS. Let's see. Vector, tail, and head equation. Oh, aren't those the... You would sort... You would sort them? Oh, okay. You can find the vector if you know the head and the tail. Ah, so we should just create equations for head and tail first. So, finding the head and the tail of a vector. So let's see. Head and tail of vector. We'll save those for now. T sub and T add are fine. But we need to find T head underscore vec. And we'll need to write out a formula for this. Or a procedure, equation, function of all time. Template of all time. We will take this T underscore. But these vectors don't represent a fixed 3-dimensional, 2-dimensional point. None of my vectors that I've written do this. They exclusively are for one thing, and that's to do anything that you want them to. I don't want to have something that you have to be like, oh, I want vec 2, vec 3. I just want to have vec, and I want to have it so it just works. Like Todd Howard, bro. Just works. Skyrim. Just works. You could climb the mountains with Fish Vector Library. Once I release it. Well, once it's ready for me to... Well, I'm already releasing it right now. Like, me writing the code on stream, that's good enough, right? Look at it, absorb it, and then write it again. I will release it after the stream, probably. I just gotta make time for that. Let's see, head to tail rule. So, to find the head, find vector head. Given magnitude, direction, or position. Alright, so here's an example. He says, 1. Calculate the magnitude of the vector. 2. Choose 2 unit vectors in the plane. In your case, I and J will do. Magnitude, direction, and position of tail at an XYZ plane. Oh, that's actually a... This is blowing my brain cells. I'll be back in a second. I gotta do some stuff. It'll be like real quick. It will be like very shortly. I'll be back. Take like 5 minutes, hopefully. Alright, I've returned. So we're gonna try to set up head and tail of Vec. Let's see. So these are for like 2-dimensional and 3-dimensional, but like what if we don't have 2 or 3-dimensional? This is like what if we have like a 4-dimensional one? Like what if we have a vector of vectors? I mean, technically it is a vector of vectors if you have like an array. A matrix is just a vector of vectors. Like it's the sum of a matrix. Vector of vectors equals matrix. So you'd have to like either handle it as a 2-dimensional or as a 3-dimensional, because 2-dimensional and 3-dimensional are different. You'd take 2 points, and one would be the head and one would be the tail. That's like the problem though, is then you have an array like what I have. We're just taking one array, passing it, trying to get a head of the array. At this point, if you have a one, this essentially means that the arrays here, we could consider this is a point and that's a point. But what are these points even? Unless you have, and technically I even have the ability to say, let's have a comma 2.143 and something like that on the other one. 4-dimensional, 5-dimensional, 6. How would you do it in 6 dimensions? There is no head at that point. But then you could also consider this is a distribution then. But what if you want to consider both? And there's 2 ways of looking at it. Like you look at it the statistical way or the practical way, where it's like statistical versus practical, where you could be like, practical is I have a line from here to here or from point A to point B, but then the statistical way would be like to sort them all out and be like the highest number is the head, lowest value is the tail. Let's do find the head of 1.2, comma 3.4, comma 5.6. Verify you're not a bot. Oh, I am a bot. I'm so sorry, guys. I am a bot. See, so the head, lowest value. But the highest value is 5.6. That's the tail. Wait, what? Oh, is it indexes? What if it was 2.4 and then 1.2 at the end, like an out of order. In standard computer, the head of the list is 2.4. So I am doing it right. Ammons? Question mark, comma, 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 comma. The magnitude wouldn't really matter. Well, the 2 magnitudes. Are these just for adding magnitudes then? Mag add, I guess? Like, what? That doesn't really tell me much. The head of a list is it would be 2.4, like the start would be that. And the tail is the end. Unless you take the head and then you send the head to squared vec. Then you calculate its square and then you give a reverse of it. And then you pass that as a magnitude. Well, that's not the magnitude though. But if you have the magnitude though, you could technically say that the magnitudes. Bro, math hurts my fucking skull. So that's just adding a vec though. So like when you have vectors, you join it head to tail. So would it just be appending one to the other? And then finding the square length, or like the regular length? Actually, this entire way of doing it is wrong. So what you would do is you would take the magnitude of both. No, you add the tail of one to the other. So in advec, I did it wrong. So advec does not take the magnitudes of the two. Instead, it actually will take and make a new array, but we're not going to want to append. I mean, we'll just call for each, and then return to type. But for each index of that, and then for each index of the next one. However, if the two vectors are not of the same length, so we'll just take for each index of both of them, we'll create a type array. We'll just actually append it to start off, because you only need to do that once. It doesn't even need to be called. However, the problem is with arrays is that when you do an append, it actually wastes performance value. So you lose performance calling the append because it has to do checking for bounds. So it's actually better to create a array of TA underscore v1 so you'd actually declare a T array called TA underscore C for carrier, and TA underscore C is going to equal TA underscore v1 dot length plus TA underscore v2 dot length. So we're setting those dot length properties on both of them to be the same, so that way it can do that and create this new array, which will then be used to sum the magnitude, which will be done afterwards. So now we have the lengths of all of them. Every iteration will take a member of each of these. So we'll take we'll do for each I to 0 to dot dot TA to TA underscore C dot length. We're gonna take a index we don't want to do any checking though. TA underscore C dot length. What do I want to do a for each for this? You can't add them together by just appending. Well, it makes sense to just append, but you don't do the bounds checking. Bounds checking, huh? Yeah. Oh, you know what we could do is just do another declaration, but I don't want to do that. I want to try to avoid that. Let's just undo all that. Let's do an append. It'd be simpler. I think simplicity would be speed. This just does it in one step too. So like, I mean, it looks good, but like obviously there is a slight overhead for the bounds checking. I'm not sure how much that is. I just know it exists. Learned about it yesterday. So don't know too much about it, but it exists. That's cool. So T underscore R equals the magnitude so effectively the first index of TA2 is that. Not that it really matters, but like you can either add the head of this one to the tail of this one, or the tail of, or the head of this one to the tail of this one. Now, that will give you a sum of what the vector is. Pretty simple. Same thing can be done with the next one, but it's slightly different. So in the next one, we do subtracting. So to subtract from it, you find the reverse direction. So how do you find a reverse direction? However, direction and magnitude are two different things. Would it just be appending them then? So vector adding would just be appending two vectors. Or this could be done by just summing two magnitudes. You wouldn't need this, you'd just sum two magnitudes together. Unless you need the total magnitude of two vectors. But even then, I think the result would be the same if you just were to take TA V1 or V2 and then do the same thing and just, you know, do it a little differently. Honestly, I don't think this is the best. However, this would tell me it's just adding magnitudes. I think it is just adding the magnitudes. But that's just for a length one, though. Ah, so the distributed one. Where's my redo button? So that's a add dist. We don't know how to do subtract this yet. That's kind of complicated. But add this would just be to add the two mags. Would be the same thing, but with an add symbol, actually. So we now have add distributions, and that just gives you a magnitude as well. And then subtracting, we find the reverse of the reverse. First we reverse the direction of the vector we want to subtract, then we add them as usual. And to find that, you just normalize. So you would normalize it. But these are for directions as well. So the length of the line shows its magnitude, and the arrowhead points in the direction. So then wouldn't it be like the same to just like so the subvec, right? That's subvec. Oh, this is advec. Advec. Subvec Subdist would be the opposite of that, probably. But in this case, they have this is more like add the length. Well, add head to tail, and then calculate the length. So that would just be to say. No, I understand what I was doing before is actually the correct way of finding it. So then. That's no longer add distribution, that's add vec. Distributions are different. Distributions are the actual vectors with their indices, not combined into a single scalar. These will be single scalar ones. That makes sense. T sub underscore vec. Now I think about it, it makes sense. Like I just popped that in my brain. My brain cells have started to kind of work now. T array subvec takes T array T A V1 comma T array. So how does this one work? So subtracting, we can also subtract, first reverse of the one we went to, subtract. All right. Where TA reductant. Reductant? Is that the word? I don't remember. And V2 something like this. I'm not a math guy. I just decided to do math because it's fun as hell. T of T underscore R equals 0. Although you can pass these as ref. Well, that one you have to take that and, well, these you need this because you do not have a scalar value to start. You have to vectors to start, so you would need to make a scalar to return a scalar value for the t, since it's not a t array. Pretty simple. But first, you reverse the direction of the vector you want to subtract. So we'll call normalize vec of TA v2, and then normalize vec returns that, but we need a magnitude, which magnitude and direction are different. Is direction just the sign? Magnitude I wonder if magnitude is length of equality, while direction indicates the categorizes scalar quantities. Whereas vector quantities... Okay. So is direction scalar? Fundamental component of a vector. Yeah, but... Oh, okay. So... Wouldn't it be represented as a scalar? By their magnitude, size, or amount. Damn. So... My brain cells have hurted? So a scalar is like an individual integer value. The problem is, I think normalized returns an array for some fucking reason. Normalize returns okay. So would you just take, it would just be the magnitude then? That would represent magnitude and direction. But like, you wouldn't want to represent magnitude and direction at the same time? Oh, now I'm getting so confused. So now we've set up normalize. This would be a normalization formula. Yields direction, but not magnitude. Yeah, because the magnitude is the sum of all of them. So we would probably normalize it and then grab the magnitude. No, you would grab the magnitude and then determine if it's negative or what. That's how you would do normalization. This is just normalizing every single index. So that's why you start with a vector, is because the vector would be the original like starting point. You wouldn't take a magnitude's direction, no, you'd take the vectors. But then what about the scalars that represent that vector, right? What about them? Vector normalization. Vector indexing. Euclidean distance. The dot product. Oh, this is the missing pieces of Fish AI. When I was trying to write that shit. The dot products, which I kind of knew, but like the dot products, bro, is super important. So actually, let's not really expand this too much anymore. I think we would change the project direction to start developing the other pieces we'll need for Fish AI. Fishenheimer itself. We'll do a compilation test, and then we'll develop functions exclusively for the target. So, we've learned quite a bit about this. It works with invec, magnitude, scalar. We just need to do a quick compilation test to make sure it's ready for usage with another program, which is why I'm writing it as a module, by the way. The reason I want to write it as a module is because I don't want to have to be like, damn, time to make a new project. Let's redo all these functions for the nth time. Which we're going to have to do that for this new one. We're going to make a tokenization thing, and then we're going to pass the tokenization token values off to the thing. I'm going to avoid bit packing on it. I think that's fine, because all we need to do is take literally just the words, cast them into characters. No, we will do the bit packing method as well. So vec.d is going to become one of my core libraries for my purposes. We're going to go ahead and begin a new project. But we need to do that compilation test. What is this? Oh, docs for that? Okay. Here, let's close out of all of this. We don't need that anymore.
36 M Chester, 0 C++ 33 M. Major Willard C++ damages the brain. Mute. 0 M.
Damn. Do. Where's it at? Where's the thingish? Thingatron, where art thou hiding? Yeah. For now, we only get advec. In fact, let's remove these, because I don't believe any of these are accurate to what we need to write out. As far as I'm concerned, this is as much as we would need to write out more advanced stuff.
M Chester, 0 C++ 33 M. All new features added to C++ are intended to fix previously new features added to C++. David Jameson.
Thank you, David Jameson. You've made my day great again. Wowies. Wowies yowie. Invert magnitude, sure, why not? Just go to that one line. Perfect. It works. Good. So, now, let's see if we can make a simple program. Import standard.dio colon write-ln. So we're going to try to implement import vec. Don't need to put a dot. And then we need to make our void main. And from void main, let's do some of this. We're going to write out some new templates too. We're going to make a new library called module Fishenheimer. Nah, let's call it something better. Call it talk. Or what do they call it? ML. That's what we'll call it. MLlib. Or let's just call it LLMlib. That's what we're building, isn't it? Or Zucklib. Zucklib? Oh, yes. Zucklib. There we go. Got ourselves the Zucklib. Soon to be meta. Actually, this makes sense, though, because I'm meta programming while I'm writing my Zucklib. So, we're going to take T of T. No, actually, this time it'll just take a string. No, actually, it'll just... This will be a return value. Technically, you can do functional programming with templates too, like hella functional programming, I think. But we're gonna insert or import after we declare the module. Let's import readln. Since we'll need that, we'll also need but will this import if I were to use this as a function? I don't think so. This is a terrible way of writing the program. However, we'll use zuclib later. So zuclib isn't going to be used right now. It's going to be used for the byte packing algorithms. So we'll write out what we need to write out in void main. So we'll do, we'll need to readln, writeln, string. Should I do this as a class object? That's a good question. Class objects aren't really great for concurrency. I don't really like classes for concurrency. It's like a fucking pain in the ass. But avoiding things ain't good for you. So I say probably don't avoid that. String array, input, follow the standard fish syntaxing, equals, then we need to call things. We need to readln dot, and we need to import standard.algorithm. Colon splitter, import A, B, C, D, E, F, G, H, I, K, L, M, N, P, Q, R, S. L comes before R. I did not remember that. Standard dot array colon array. That way you can take an array, take a lazy generated range and make it into an array. Bet this will work. And then this one needs to be like this. And if, and we need to import standard.algorithm.searching. Not yet, I'm not ready for that yet. Technically, the result of this could be defined as a function in the zuclib. Since I do use this frequently for like literally so much different programs. So we might just send this to there and use it there, but this thing's pretty simple. All it's going to do, all this does is it takes, it makes a string array SA input, and SA input is going to be used to determine if SA input can find any indexes of that, then we'll need to in turn do a for each loop. S underscore mem technically, one way of doing this is to define a, and this is the easiest way to do it. However, something I'm gonna try is, well, actually, no, you would need to do this. So you'd call another string array. That's the way I usually do it. String array SA underscore ret. Let's call this into a, we'll make a new function for this one as well. Void zuck parse or parserberg. Mark parse or zuck parserberg. Something like that. Parser. SA, actually it's VFN for these. VF underscore parser. Take this, boom, boom, boom. That's gonna be the void function parser. We don't need to do a for each. So you would do for each I of, I don't know, from the SA input to, and the reason I put it in an if is because you don't want to call this function unless, you know, string array STAFN string array function parser. So that's an if, that's a declaration. I to dot dot s, or from 0 to dot dot SA underscore input dot length. And then we would set the length of this needs to equal new string array of SA underscore input dot length. I don't know how well that's gonna work. Now for each I of it, then the SA underscore ret of I is gonna equal SA. You would actually declare this in a third layer. Instead of avoiding that fourth layer, we have to do it like this. So we'll take this and do that crazy shit I was about to do. So I know this is 4 layers deep, but who cares? I don't care about the 4 layers deep rule. My only 2 rules when I write my code to make it look clean nowadays is do this and then a space here. That's it. Oh, well, also everything has to have some descriptor of what it is, since I like that. So for example, Safin is string array function parser. That makes sense, right? Like you could tell what that is. You're like, oh, I've seen VFN 3 times. I know that means void function. T is a template. Pretty cool, right? Makes a lot of sense. Module zucklib makes a lot of sense so far. Return of I equals SA underscore input of I. However, we can't do the... See, this will just initialize all indexes. But we could do it differently and say, do it with ternary. So ternary operators will make it not go past this certain amount, because you know the deeper you go, the dumber it looks. So nesting bad is what people say. But SA underscore input or return can equal this. This is going to be beautiful. And then afterwards, that's going to be fun. And it can either equal nothing or, well, actually, the whole reason you'd want it is to skip a value. you'd want to skip values in that. So that's the idea is we're not taking anything that becomes this. So if it can find that, then we need to just have a remove. So a string array remove function. Void rem from SA VFN. You do like SA underscore, so that means it applies to that. It's a void function, and that it cleaner. I'm sorry, let's call it cleaner what it is. And then you just do this. Be like, ah, yes, we have SAF VFN cleaner, string array, void function cleaner, so we know it's a string array. Actually, let's say that those go at the end. So it's a VFN cleaner for SA. That sounds way better. Don't save that yet. We're not ready to save it. Actually, let's just save it at this point. I mean, I always default to saving after I write a line. We're gonna call this one AI lib. AI test dot D. So AI test dot D, and then we'll have zucklib afterwards. Discard zucklib for now. Zucklib will be the greatest programming library in all of history. That's right, programming history matters the most. But we'll call VFN underscore cleaner. Technically now, it'd make more sense to pass a member. And this will take a string s underscore remove. So we'll do that. Now, void would apply to, it also needs to take an SA, though. So how do you pass that? So you would just pass the string array, and then what you want to remove. String, you do string array. Call it SA target, I don't know. Oh, SA input? Sure, why not? This way, if you wanted to use it somewhere else, you can use strings anywhere else. So that's cool. VFN cleaner underscore SA, SA underscore input, and string S rem. Let's see. What are we doing next? So VFN cleaner takes this, and if it can find that, well, no, we already know that if it can find that. We'll take a ref of the, no, it takes a string for S input, because those would be S at that point. So it'd take a ref string, and SA input, and a string S remove, and that's how you would call this one. And it would return a, it'd set string to equal that, but here's the issue is that you'd have to, bro, I'm just doing this wrong. I'm just doing this bad. Just use if. What am I doing? Hello. Hello, RMSV49. How is it going today? Let's see. If... Fuck it, just nest it. It makes it simple. Keep it simple, stupid. That's what Arch Linux says. So you could do regular checking, or you could do the reverse. If does not equal and what we're trying to find, which is this, then append to, or SA of input, SA underscore ret should append it. You don't want to do this. That makes no sense. Technically, you could do it that way, but you just, instead of doing this, you'd call SA input appends. You don't even need that. You just need mem. Yes, this makes sense now. See, I was doing it all wrong, trying to reinvent the wheel here, but this literally is the best way of doing it. The only problem with this is you could technically avoid bounds checking by not doing an append. So there's that, which kind of eliminates some of the overhead. So s underscore mem gets appended to an SA return, and the return value is then dispatched back to the main program from there. We'll carry it over. So the return value after that, and that is the parser, so that avoids any potential that we create some diabolical, disgusting, gross slop code in our zucklib when we write zucklib. We've built the temple out of fucking scopes and nesting, so that's good. Then we'll call veclib on this afterwards, but we'll take the string array of SAFN parser. So return SA underscore ret. That should work. So if we return SA underscore ret, we need to pass that either to another string array, or we go straight into byte packing. So we could write our byte packing algorithm now. But let's make sure it compiles first.
36 M Chester, 0 C++ 33 N. C++ glacial compiles, insane complexity, impenetrable errors, multiple cross-platform compat, basically useless tools. Adam Budeman.
Thank you, Adam Budeman.
36 M Chester, 0 C++ 33 N. I invented the term object-oriented, and I can tell you I did not have C++ in mind.
Thank you, Jester 2.
0 M. 36 M Chester, 0 C++ 33.
Oh god, I'm failing.
Things wrong with C++, the initial concept and the implementation.
Did I just do dot length?
Bertrand Meyer.
That makes sense.
0 M.
Let's go ahead and
36 M Chester, 0 C++ 33 N.
Oh, I import vec already.
Languages designed for other people to use have been banned. COBOL, PLI, Haskell, Ada, C++. The good languages have been those that were designed for their own creators.
C, Perl, Smalltalk, Lisp.
Paul Green. 0 M.
Damn, bro. Variable SA underscore return is a fine. Where did I say? Oh, I'm a dumb fella who just wrote that shit. ./AI test. Doesn't do anything yet because we didn't even call SAFN parser. Let's call SAFN parser and do that for now. And then we'll do .writeLN. Prove that it works.
M Chester, 0 C++ 33 N. C++, an octopus made by nailing extra legs onto a dog. Steve Taylor, 0 M.
So what's going on here? Let's figure that out. So we have string input, which is equals a readln dot splitter for spaces and dot array and string array SA underscore rets semicolon is declared afterwards. And then we have if SA input dot can find. However, if it can't find any indexes where it's wrong, it also needs to do a handling for that. And then it will return SA ret. But if it doesn't do that, it returns SA underscore input.
36 Jester 0 C++ 33 N. Why do C++ programmers prefer dark mode? Because light attracts bugs. Maggie Nephew SMA.
Thank you, Maggie Nephew SMA. And that's another thing. We need to not return that. So we need to remove from that index there. So we need to, in this line, somehow remove that, which would have been called in one of my former programs. Let's check. Probably this one. Probably had a good way of doing it here. So words equals W of that was the original way of doing it. So here we would do a similar thing. We could just say SA input equals readln. Then we would do SA underscore input equals SA underscore input dot splitter dot array with our delimiter. And that should actually work.
36 Jester 0 C++ 33 N. I consider C++ the most significant technical hazard to the survival of your project, and do so without apologies. Alistair Cockburn. 0 N.
Bruh, this is our new, my new co-host, by the way. It's Jester. Bro, Jester is a fucking goat, bro. He's been on the channel for a while now. But now he's finally got a voice too. Thanks to the research yesterday. Then we would take SA input. String S input equals SA input. And then you would take this, but you wouldn't return that, obviously. Well, you'd still return that SA input. We just have to operate on every single reference member of it, but anyway. And this only needs to be defined inside the if block, because if I define it inside the if block, then it won't be used otherwise. Like, it will still be there in, like, the memory, but it won't really matter because it's not really that intensive to put it there, I guess. I don't know. Fucking use your brain, it makes sense. We won't have to call it every single time. Calls are worse than having them just in memory, because then it uses CPU resources, and we're trying to core max.
36 Jester 0 C++ 33 N. To me, C++ seems to be a language that has sacrificed orthogonality and elegance for random expediency.
Thank you.
Page Jones. 0 M.
Oh, it's not in scope. Because that's actually fucking confusing. You know how many times this gotten me so far? It's got me like 20 times now. But yeah, it needs to be defined in there. So there's one less string array. That gets me every time. That's the new thing with that, but that's fine. But it only gives you the /n. So that's because you need to take S input Oh my god. Oh my god. Dot splitter for a new line character. Or we could just do dot remove n. Dot remove slash n. Sudo dot remove. I DMD'd it, right? So like what is dot length minus 1? 0 to length minus 1. Does it need minus 2 then? Which it will find. You don't even need to check that. It will always have a new line character unless it was done some other way. So then you would do. Hold on, we need to open that one program again. Static words. Maybe it's because I'm doing a declaration. Oh, maybe I'm not passing it correctly. What if it did this one instead? That looks good though, like it should work. Maybe I should define this earlier on in the program. Let's see. Let's try defining this earlier on without initializing it, and then define it and initialize it on this line here. I don't like that. It takes more lines of code, but I think it might need that. Yeah, just needed that. Kind of know a thing or two. But here's what we can do. For safety, the GC will collect on the end of the scope. So, let's try this shit. And then you have your if statement. This looks really good. I think this is the peak of coding. Every programmer on planet Earth would want me on their team. They'd be like, damn fish, you got the hella cooking programming language. You're hella cooking with that programming you're doing. And I'd say yeah, hella cooking. So that returns that. And so once you have a string array from SAFN parser, I think we'll need another function so that will parse down every single index of the string array. So you would call, like, I don't know. And then we'd make a vector from it. So we would basically take every index, byte pack them. So we'll do a byte packing algorithm. But it's not gonna have, it can't be void. It has to return a, depends on what we want the array to be actually. We could do a double array, which can also be specified whether you want 86 or not. 87 extensions and shit like that. There's two extensions to it, the 86 and the 87. It's going to be interesting to look at. So let's say we have dlang float 86 or 87. Let's see about this. So there was at one point an x87 floating point related subset. The 8086. Oh, so like really early computing. Intel was still around, was started right around then, I guess. In the form of optional floating point coprocessors, FPU, that work in tandem with corresponding x86 CPUs have names ending in 87, also known as the NPX number processor extension. So these are like really old though. There are instructions to push, calculate, and plop values on this stack. F square root, FP tan, etc. So do they still check this with modern, like CPU, LS CPU and shit, right? But that's not a concern. I don't think D-Link has that. Although I did read that you can define to use the x86 extension. Although I'm pretty sure it will just default to that. Anyway, because if you compile with LLVM, your code kind of just gets transpiled into like somebody else's code, or like into the most optimized code, quotation marks. Which I like LLVM; it's really good. But I think that's one of the only concerns I'd have with LLVM is that somebody else didn't write very good code with it. Well, let's make a double array. I think that'd be the most easy way to pack them. Let's try and find out the double bit size then, since I need a double bit size. Double bit size D-Link. I believe it's 64. IEE 754 floating point. Yeah. Okay, so we can pack 64 bits into it. So instead of doing pairs, we'll just do... Well, actually, it was easier to do the lexicon with pairs. So do you use shorts instead? No. What is float? Float is 32-bit? Then what's half float? I guess a U short would be like the way to go. Or just do a short then. The short is all we need. And then the short can be vectorized as a float later on. But there is some questions with that. I think this is... I need to take a break for a bit. Probably come back to this later. I'd like to thank you all for watching. I'll see you guys next time. And goodbye. I have to end today's episode here, unfortunately. So, what we did today, we went through all of this. We did some math today for fucking vec math, and then tested some of this shit, and then talked about square roots and shit. Oh, we did some cool shit. I'll see you guys next time, and